All right, here we go. This problem is going to be much similar, very similar to the last one. I'm given sine again, and this time I will deal with sine and therefore find cosine and tangent. This also gives me a restriction, and it says that the angle has to be between pi and 3 pi over 2. So my drawing here is going to be very, very important. All right, so let's do it. So here is my drawing. I know that this is 0. This is pi, which means that this is pi over 2. Remember, it's positive as we go counterclockwise. And then this would be 3 pi over 2. Now, because of that, the angle needs to be between pi and 3 pi over 2, which means I'm looking in this quadrant right here. So I'm going to ignore any others. It's just this quadrant between pi and 3 pi over 2 that I want to focus on. So now I'm going to look at sine. So now sine of theta equals negative 3 over 4. There's a couple of ways of doing this again. We can do it in both the ways that we did before. If the sign is negative, now remember sine from our discussion in class, sine always refers to the y. So if you have a negative sign, that means that the y value needs to be negative. Okay? Now, of course, this is the opposite over the hypotenuse. So if you want to think about it that way, then either of these would work. Of course, we are limited to pi to 3 pi over 2. So this one we can completely ignore. And then opposite would be 3, and the hypotenuse would be 4. The hypotenuse will always have a positive length. Okay, we won't ever have a negative there. Even though the tangent can be positive or negative, the actual length of the hypotenuse will always be positive. Now that makes this part negative, which is why we have the negative 3 over 4. And so now I can go ahead and use Pythagorean theorem to find my x. All right, so we go ahead and we say, all right, we do negative 3 squared plus x squared equals 4 squared, and so that's 9 plus x squared equals 16. We subtract the 9 from both sides, and we get x squared equals 7. Take the square root of both sides, and we get x equals plus or minus root 7. Now, which one of those is the one that we want? Well, again, we're looking for the one in this quadrant right here, which means I need to go to the left. So that would be the negative root 7. So, therefore, this is negative root 7. And so I can now get cosine. I can say cosine of theta equals the adjacent, which is negative root 7 over the hypotenuse, negative 7 over 4. I can also get tangent, because the tangent of theta is the opposite, which is negative 3, over the adjacent, which is negative root 7. And again, IB doesn't really care about this. You can just leave it as 3 over root 7. Now, if your nerves are just driving you crazy because you're so set on the fact of rationalizing this, go ahead, rationalize it. It would be 3 root 7 over 7. Now, I'm not going to go through that process. If you need to learn how to rationalize, then go watch a video on rationalization. Don't watch one on trig. All right, here we go. Let's look at this in another way. Now, we can get this similarly by doing the sine squared of theta plus cosine squared of theta equals 1. So sine, of course, is negative 3/4. So negative 3 over 4 squared plus cosine squared of theta equals 1. That will give us 9 over 16, because I'm squaring the top, squaring the bottom, plus cosine squared of theta. Subtract the 9 over 16. This cursor would kill me right now because I did the little slanty thing, and you know what? I don't care. So then we have cosine squared of theta, which equals 16 over 16 minus 9 over 16 would be 7 over 16. Then we square root both sides, and we get cosine of theta equals plus or minus. Now here I've got the root 7. Now, because of the 16 on the bottom, the square root of 16 is 4. And again, I'm looking for the one in this specific quadrant, and so therefore I know it has to be the one that has a negative cosine, so therefore just negative root 7 over 4. Now I can get tangent fairly easily. If you didn't know this, you now do. Tangent is the sine over the cosine. And if you do sine over cosine, which was, let's see, sine was negative 3 over 4, and cosine was root 7 over 4 negative, then you end up getting 3 over root 7, which, strangely enough, is what we ended up with over here. So there you go, two ways of doing it, one using the trig identity, and one by using Pythagorean theorem and just a simple triangle, both using the graph, using the picture to help us accomplish the feat. All right, I'll do one more in the next video. Ciao.